Hello, welcome back to our little experiment of writing a web server in C. So in the previous video, we were able to get to a stage where we can display a simple web page with the to-do list items and also able to interact with it a little bit. So before we get to the deployment stage and add the finishing touch, there's one little thing remaining. So far we have been storing everything in memory. That means every time we restart the application, all the to-do lists we have added so far is lost. So it's time to fix that. So I don't want to add any sophisticated databases or anything like that. So what I'm going to do is instead of storing it in the memory, I'm going to store it in a file in disk. So each time we need to access the to-do list, it will be read from the file, and whenever we add a new to-do, it will be appended to the file. So this way it will be persistent, and we can also deploy it somewhere. Okay, so let's get to it. First of all, I'm going to define a name for the file. So let's say db name is todos.bin. Okay, so it's going to be a binary file which is going to contain all the to-do list. So what we're going to do is write the list of to-do lists as a binary into this file, and to keep it simple, we'll just write it in the same folder. Okay, and that means we will have to add it to the git ignore as well. Git ignore db. Okay, leaving that out of the way, what else do we need? So we can get rid of these things. We don't need this in the memory anymore. Okay, so to do's add, let's keep it as it is, so we can use this method to add it to the db instead of the memory. Okay, and do we need any other methods? Yes, we can have a to-do's read as well. So to-do's read, and the parameters, let's take a int stars parameter. So this method will read the to-do list, return back the pointer, and it will also modify this count parameter with the list of items, the count of items it has read. Okay, let's implement that function. I think it's easier to implement the to-do's add first, and then we'll see. So basically, oh no, not really. I think we should implement the to-do's read first. So we have an idea of how the bytes are packed inside the file, then it will be easier to implement the to-do's add. This is a bit more complicated because we are not really writing everything into disk. Instead, we are appending it to the disk. So let's implement this. To-do's read. We will keep this method also here. Okay. So let's open the file. Open db name, and we will open it as a read mode for binary. So if the file is null, we don't want error out here because initially the file is going to be null because it doesn't exist anymore initially. So in that case, we would just set the count as 0 and then return null. Okay, so it just means that there are nothing yet. So we will handle creating the file in the right method. Now we'll have to read this. So the way I think is, so the first byte in the file will be the number of to-doist items, and then it follows a list of to-do lists, and for each it starts with the ID. So first byte will be ID, and so the title, the first byte will be, sorry, the first integer will be the length of the title. And so once we read the length of the title, we know how many bytes to read next to get the actual title. So this is how we store like a dynamic string in a file. If this was like a fixed character string, it would have been much easier. We can write the whole struct in one go. But let's go this way. So first we read the count, size of int one file. So we read one object or one element from the file with the size of integer. So this will be stored to the count. So the first 4 bytes I think will be in the count of to-do lists in the file. And if this doesn't work, unable to read to-do count from db. Okay, and again we will set the count to 0 and return null. Actually, we will also close the file. Okay, now we have the count, so we can allocate the memory for it. Todos equal to malloc count into size of to do. Okay, and then what else? So we have the list, the count, we have memory allocated. We can now iterate this many times and read the to-dos one by one. So for int I equals to 0, I less than star count plus. So first thing is f read to-dos. So the first thing is we will be reading the id, to-dos I.id. This is an integer 1 and a file, so we should be reading one element here. If not, error, I will read to-do id. Okay, and we will just break out of this. So then we need to read the length of the title. So for that we need a variable, and the same thing actually. So here we will be reading the length to do title length. Okay, so now we have the length here. Let's allocate the memory for that. Malloc. Okay, so remember this is a null terminated string, so allocating as much memory as this length should be sufficient to store the whole title along with the /0. Okay, now we can read the whole title. To this title, so here each element will be size of char, but the length will be len. Most equals to len to do title. Okay, so we loop through the entire list and read everything one by one. So once this is done, we can close the file and return to-dos. Let's see if it compiles. Of course not. We'll have to modify all the other methods which uses the to-do list. So undeclared identified to-do. Okay, where is it? Size of capital to-do. Okay, unsigned long and int, so this should be casted to unsigned long. Okay, I think that's pretty much it for this method. Now we need to fix all the existing methods which make use of the to-do list. So we don't have to allocate this here. already in the file. Look how simple the main method has become. For the get to-dos, so here we are expecting a to-do list and also a to-do list count. Let's declare that to-do list count and to-do underscore list equals to to-dos read, pass the to-do list count. Okay, much better. And this is now an integer instead of size t. It's 65. Same here, we'll have to do the same thing in the index as well. Handle index. Okay, much better. So now the build is successful. We just had to implement the to-dos add method. Now if we run this, I'm pretty sure it's going to fail because we don't have anything. Localhost, we don't have any to-do list at the moment. Okay, it's not failing at least, and this is not gonna work because we haven't implemented the add part. So this is a bit tricky. So we need to adhere to the format, but I don't want to read everything and write everything back. So instead what I'm going to do is, so the first 4 bytes in the file is going to be the size or the number of to-dos. So I'm going to read that first and then increment it by 1 because we are going to add a new to-do in the array, and then append the whole to-do object at the end of the file and also update this count by incrementing by 1. So this way we just modify the part of the file where we need it instead of rewriting the whole file. Just a little optimization. For a program this size, it doesn't really matter that much, but it's a nice exercise to add. Okay, so first of all we need to construct the to-do object, of course. So to-do equals to title. So I'm not going to duplicate the title string because we don't care, because after we write this it doesn't matter. Then we open the file equals to f open. So this time we are going to open it in r+p format because we need to be able to read it and also append the file at the end. Okay, now we need to read the count first. So first of all we need to check whether the file exists or not. So if the file was null, that probably means the file doesn't exist. Then we can open the file, in a write format. So this will create the file, and if this is also null, that means it's pretty bad. So this is also null, that means we are not able to create the file. So let's print an error, unable to create db file. There's nothing to do here. In this case it's definitely a failure. Exit failure. Okay, so here we got the file, and let's write the count back. So we are going to write the count size of int1 file. So since we initialize the file here, let's write the count back. So this will be 0. So we initialize the file with a 0 count and no elements. Okay, so if the file was not null, that means we got the file, and here we can read the count back. So f read count size of int file. it is not equals to 1, p error unable to read count. F close and exit. Okay, we have the count here, so let's increment it. Now we need to go to the beginning of the file and write the count. Nope, actually we should append the to do first and then update the count at the end. That way it's a bit more safe. So for that we need to seek to the end. So fseek file 0 seek underscore end. Okay, so we are going to go to the end of the file, then fwrite to do.id. Okay, size of int one file. So we wrote the to do id. Now remember, for the title we have to write the title length first and then the title itself. So title length equals to strlen to do the title. Wait a second, did I forget to add the id here? Yes, right. Yep, don't forget that. So this will be the size of the title plus 1 for the null terminator. Then we can write this fwrite title length title length to do dot title. What am I doing? So this will be the size of int one file. This writes the title length. Then we can write the actual title itself. To do the title size of char and title length. And the file, of course. So we wrote the to do id, title length and the title. Now let's seek back to the beginning, and we need to seek back to the beginning and write the count back. fseek file 0. What's the parameter here? fseek geeks or geek. Okay, secant seek set. Okay, that's what we need. So this will go to the beginning of the file and then fwrite count. So remember, we already incremented the count. Okay, perfect. So we wrote the to do here and then went back to the beginning of the file, updated the count and closed the file. Hope that worked. Perfect. Let's read this again and test it. Go shopping. Awesome. So we now have, let's look at the directory. As you can see, it has created the bin function, sorry, the bin file. So if I do a hex dump, you can see that it has worked. So here in the first byte, you can see that the count is 1, and somewhere in the middle you can see the title. So go shopping starts somewhere here, I think, and this 0c I believe is the length of the string title. Let's try to add one more. Wash clothes, create PR. Let's see. So now the count is 3, looking good. You can see the remaining 2 here as well. So there we go. Perfect, we now have a database kind of written into the disk, and it's persistent now. That means we can now package this and deploy it in an actual server. So I'm gonna make this video a bit short and stop it here. I think it's has been a great achievement so far. So in the next video we will see how we can package this as a Docker container and deploy it in a Kubernetes cluster. Stay tuned.